All right, so today we're going to do a little more solving trig equations by using factoring. So you're going to factor, find general solutions, and then find all our solutions on a given interval. And in this case, we're not always going to have things squared. I know we think of factoring as always requiring something squared, but here we have a mix of different trig functions. We are still going to use the idea of factoring. In this case, we are looking for a common factor. So if I think here, there's a sign and there's a sign there, and even there's numbers. If I think about my numbers, I have a 4 and a 2. And so what's in common in both the front piece and the back piece? The front piece has a 2, the back piece has a 2. The front piece has a sine theta, the back piece has a sine theta. So that is what I can factor out. That is my biggest common factor. When I divide 4, or the 2 out of 4, I'm left with a 2 inside. And when I divide out the sine, I'm left with a 2 cosine theta. And then in the back, I have factored out everything, and I'm left with 1. It is always a good idea to check if I distributed 2 sine theta times 2 cosine theta would give me my first term up here of 4 sine theta cosine theta. And if I multiplied 2 sine theta times 1, it would give me my back term of 2 sine theta. So that's my start. I now have 2 different things multiplied together and equal to 0. This only works, factoring only works in this way if my product is 0, because then what happens is either the first part, which is 2 sine theta, is 0, or 2 cosine theta plus 1 is 0. That is true. If 2 things multiply to make 0, either one or the other is 0. And now I solve each part. So in this case, I have 2 sine theta is 0. I'm going to divide my 2, and I get sine theta is 0. And so I think about my solutions. Where is my sine 0? This is the no calculator part, so I'm using my brain. Sine is my y on a unit circle. So where am I at 0? At 0 and at 180. So I'd have 0 degrees plus 360n, or 180 degrees plus 360n. If you think about our inverse sine of 0 is 0, and this right here would be 180 minus inverse sine, which would be 180 minus 0. So there's my 2 solutions for that, generally. Over here, I can solve by subtracting my 1. 2 cosine of theta is negative 1. And then I divide my 2. Cosine theta is negative 1/2. So I've undone all my outside transformations. There are no inside transformations. So now I'm at my find my angles. Cosine is negative in quadrants 2 and 3. And the cosine is the 1/2 is the small side of the 30, 60, 90. So if this is the 1 and this is the 2, then this would be the 60. Or however you do it. I think small side is 1/2, big side is root 3 over 2. So opposite, this is my big side, this is my small side. That must be the 60. And if you don't realize that 1 over 2 is in the 30, 60, 90, you are in serious trouble, and you need to get some help with how to do this. So my solutions then, one answer is if my reference angle is 60, I get 120 plus any multiple of 360, forward or backward. And my other answer, you could do negative 120, that idea of plus and minus cosine inverse, or I can use the number I know, which is also 240 plus 360n. And there are times when using negative 120 would be good, in particular if I'm looking for negative solutions. However, I want solutions from 0 to 720. So I want to find all of my solutions from 0 to 720. So these right here, this is the first part. This is the general solution. This and this represents every possible angle for theta that will make my original statement true. And now I want to know what are the possibilities from 0 to 720. So I have 0, and if I add 360, I get 360. And if I add another 360, I get 720. And if I add 360, I will be more than 720. From the bottom equation, I get 180. And if I add 360, I get 540. And if I add any more, I will be too big. Over here, I have 120. And if I add 360 to that, I get 480. And if I add even 300, I'll be too big. So adding 360 will definitely be too big. On the bottom, I get 240. And if I add 360, I am going to get 600. And there's all my answers from 0 to 720. All right, so let's try another one. Again, I'm looking for common factors. That is always where we start with factoring. And I see the front part has a tangent theta and the back part has a tangent theta. So I can factor out a tangent theta. What's left in front is sine squared theta. What's left in the back, when you divide out tangent theta, there is actually something left. That something will be 1. It's sort of the placeholder. Oh, and I'm going to say that that equals 0. If I don't have that, when I distribute back in, I would only get the tangent theta sine squared theta. I wouldn't get minus tangent theta. This one is one of those problems where we need to do a little more factoring, because now I have sine squared theta minus 1 is 0. And I can factor that. I have a sine theta up front and a sine theta in the back. That gives me my sine squared. What multiplies to make negative 1? A negative 1 and a positive 1, right? I have my sine squared from my first. My OI, I get a positive 1 sine theta, a negative 1 sine theta, and then the L, the last times the last, I get negative 1. And there's my middle. All right, so now I have 3 options. Either tangent of theta is 0, or sine theta minus 1 is 0, or sine theta plus 1 is 0. Tangent is 0 when my slope is 0. So again, theta is 0 degrees plus any multiple of 180. So at 0, at 180, at 360, at 540, and 450, so on. No, 540. Where's my sine 1? Again, sine is my y value. I am 1, or my hypotenuse and my opposite are the same up at the very top. So theta is 90 plus 360n. My other answer is 180 minus 90, which is also 90. This is one of those ones that only has the one answer. And then where is sine theta equal to negative 1? That happens at my very bottom, so at 270 plus 360n. So there are my, in this case, only 3 general solutions, right? I want all my answers negative 360 to 360. So I get 0. If I add 180, I get 180. If I add another 180, I get 360. Now if I go any bigger, I'm too big, but I have to think about going backwards. If I subtract 180 from 0, I get negative 180. And if I subtract 180, I get negative 360. Here, starting with 90, now if I add 360, I will be above 360. But I can subtract 360 and get negative 270. So that piece right there contributes those 2 solutions. And then I finally have this one, 270. And if I add 360, I'm too big. But if I subtract 360, I get negative 90. And there are all of my solutions. So basically, all of my corners from negative 360 to 360 are solutions for that equation. All right. We can try another one. Now where we have a number in front that is not 1. And so now we are actually thinking of factoring more like how we normally think of factoring, with something in front. And to get a 5 tangent squared, I'm going to need a 5 tangent theta and a tangent of theta. And now I prefer the guess and check method. You can try and do a split the middle, but I like the guess and check, especially with a number like 3. I have 2 options really, since everything's positive. I could do plus 3 and plus 1, or plus 1 and plus 3, but I think by luck I have hit on the right answer right away, because this would give me 5 tangent theta, and 3 tangent theta will give me my correct middle of 8 tangent theta. So what we have now is I have factored it. Now I set each factor equal to 0. 5 tangent of theta plus 3 is 0, or tangent of theta plus 1 is 0. In this case, I undo my outside transformations. Find tangent of theta is negative 3. Tangent of theta is negative 3/5. So I'm going to put that one on hold for now because that's not one I know in my head. If I come over here, though, tangent of theta is negative 1. Opposite to adjacent is negative 1, or my slope is negative 1, and that happens at the 45s in quadrants 2 and 4. And so I get theta is 135 plus 180n. There's my general solution right there. If I want all my answers 0 to 720, my next answer is actually this one right there. So I have 135. I have 315. If I add 180, I get 495. And if I add another 180, I get 675. So that's another answer, 675. There's my 4 answers there. Now this one right here is leading into the next part, which is actually using our calculator. Because I can find an answer using a calculator. What I need to do is, theta is, well, we could really say arctan, the angle whose tangent is negative 3/5, right? And what is that? It's the inverse tan of negative 3/5 plus 180n. So there's my general solution. Again, here's my general solution, and here's my other part of my general solution. That part is the general solution part. Now to find specific solutions, I need to figure out where's my tangent equal to negative 3/5. So I'm going to go to my calculator, and I want to be in degree mode because I'm doing this problem in degree mode. And I'm going to do inverse tangent of negative 3/5. So there is one answer. Now I only wanted positive answers. But since tangent was negative, I was in quadrant 4, and it gave me the negative because the inverse tan is from negative 90 to 90. So more answers happen multiples of 180 away. So I'm going to add 180. And there's my next answer. That's actually my first answer between 0 and 720. And I can find another one. And I can find another one. So I'm going to pull these over right now while I still can. And I think I should have one more. And indeed, there it is at 689. If I do one more, I'm going to be too big, right? There we go. So there's our 4 answers for this. So there are 8 total answers from 0 to 720. All right, and that leads to the calculator section. Let's try one more with the calculator. Yeah, let's try this one. So let's try one. Actually, we haven't done a cosine one yet. Let's try a cosine one. Now in this case, I have things on both sides of the equation, which is not good. It is not equal to 0. Factoring only helps if it's equal to 0. So to set it equal to 0, I'm going to subtract 4 cosine theta from both sides. So I have cosine squared theta minus 4 cosine theta. And again, we always should start by trying to factor out the biggest common factor. And in that case, my common factor is cosine of theta. What's left in front is cosine theta. What's left in back is 4. And again, this should make sense because cosine times cosine will give me my cosine squared, and cosine times negative 4 will give me my minus 4 cosine theta. All right, so now I have it factored. Next step, set each factor equal to 0. So either cosine of theta is 0 or cosine theta minus 4 is 0. This is the calculator section. You can use your calculator to tell you where the cosine is 0, but I know cosine is 0 when my x-coordinate is 0. So at the top and the bottom, theta is 90 plus 360n or negative 90, otherwise known as 270 plus 360n. And over here, right, and I would get that same answer. Let's see if I do inverse cosine 0. Boom, there's my 90. And then I have negative 90 as the other answer because it's plus and minus cosine inverse. Let's try the other one though. Cosine of theta minus 4 equals 0. Add 4 to both sides. So cosine of theta is 4. And theta, arc cosine 4. I hope that you will see, right now I know that this will give me no answers. Because my ratio, remember, we arc cosine, or this right here, my answer for cosine is a ratio. Where's my cosine ratio? 4. Where is adjacent to hypotenuse? 4 to 1? The adjacent side can never be as big as the hypotenuse. And if you try to inverse cosine 4, it's going to give you an error message. Error domain. You can't find an angle that has a cosine ratio of 4 because the adjacent will never be bigger than the hypotenuse. So hopefully with this you have enough to be able to go and tackle the homework tomorrow. So good luck.